Assalamu alaikum, sir.
Alaikum. Bismillahirrahmanirrahim. Assalamu alaikum, respected faculty members. Welcome to the learning session of Biostatics and Medical Research. Today's webinar has been jointly organized by Department of Community Medicine and ORIC. It is often said there are three kinds of lies: damn lies, and statistics. Actually, statistics do not lie, humans do lie. With the help of statistics, you can prove anything. So these are the learning outcomes of today's discussion webinar. At the end of the webinar, you should be able to define what is variable. Of course, when you do research, you define variable in your study, and what is data, what are various types. This is basic. All the further analysis, whether a descriptive analysis, whether it is inferential statistic analysis, it all depends on that. If you know correctly what type of data, what type of variable is in your study, then when you should calculate mean, when you should calculate median, when you should calculate the percentage, when you should calculate frequencies in your study. So these are called all measure of central tendency, and then measure of dispersion. How much dispersion is in your data in the form of range and standard deviation. Now, what is the difference between standard error and standard deviation? Some investigators, they use mean plus minus standard error, whereas standard error should not be used in the once you describe the dispersion of data. In the dispersion of data, you use mean plus minus standard deviation. Standard error is used to define the precision, how representative your sample estimate to the actual population estimate. So people also wrongly use standard error. Then what is the normal distribution? What is the, when your data is normally distributed, when it is skewed distribution? That also is very important, because whether you apply parametric test, chi-square test, a t-test, or ANOVA, it all depends upon the, or you apply the Mann-Whitney test, Wilcoxon test, it all depends on the type of distribution. So there are methods also we will discuss, inshallah. Then of course, when you should make table in your research article, when you should make graphs, and if there are graphs, whether you should make pie chart or bar chart or histogram or box and whisker plot or scatter diagram. So this we will inshallah discuss one by one. And then these are the numerical. Of course, there are two methods of data presentation of descriptive statistics. Once you carry out study, first you try to present the data in the form of descriptive form, in the form of the tables or graphs or mean, median, mode, percentage, frequencies. Then of course, in inferential statistics, you apply various tests of significance to see the significance of association between your findings, or you see the significant difference between two groups or more than two groups. So for that you apply test of significance, which give you the p-value. And similarly, nowadays there is also trend of confidence interval. They say p-value is not sufficient nowadays. It only tells the significance association. It does not tell the effect size. For clinicians, effect size is very important, because sometimes p-value is significant, but effect size, clinical significance is not there. So it is not very useful. Confidence interval all tells you the effect size. So along with the p-value, nowadays the researchers should also give the confidence interval. We will discuss what is confidence interval and what is significance. Now, biostatics, bio means life, statistics means science of facts and figures. You can say it is the branch of statistics that concerned with the application of statistical methods to medical and biological data. Why we use statistics? Because research is fundamental and integral part of professional academia. Biostatics is essentially needed to plan, conduct, and publish research. Because without statistical analysis, nobody will accept your finding. Nobody will accept your claim that you say there is a difference between two groups. Yeah, there is association between two risk factor and disease. Nobody will accept your claim until you prove your claim with the help of statistics. So you cannot do research without understanding the biostatics. If we lack knowledge about biostatics, we make blunders in name of research. So we must have elementary knowledge at least of the biostatics. Similarly, for using the SPSS, you must also have, SPSS does not teach you statistics. It only tells you the various procedures, test, but basic knowledge of biostatics is very essential in order to apply those procedures. To give answers of our daily lives, we use statistics. How many males and females are present here? What is the mortality rate of Pakistan? What is the proportion of male and female students in the class? What is the risk to develop lung cancer for those who are smokers? All these answers can be replied by the statistics. So one does not simply do research without understanding the basic concept of statistics. Not possible. Now, what is variable? Variable, any aspect, any characteristics of individual or thing that is measured, assessed, judged, or observed, or recorded. Variable in your studies may be blood pressure, height, weight, age, gender, marital status, heart rate, response to medication, etc. It is called variable because it can vary from subject to subject. Blood pressure not same in all your study participant. Height is not same. Weight is not same. Age is not same. So that is why it is called variable. Now the values taken by variable, it is called data. So data are the raw material of statistics. Now, according to association, once you do analysis in the SPSS, sometimes it also asks you what is the dependent variable. You have to define dependent variable, independent variable. Independent variables is used to describe or measure the factor that are assumed to cause or at least to influence the problem. For example, smoking causes lung cancer. It is independent variable in lung cancer, whereas resulted outcome lung cancer is a dependent variable. And sometimes there is a third variable in your study, which is called confounding variable, which is associated both with the exposure and disease and distributed unequally in study and control groups. And it can distort your study results. If you do not take care of this confounding factor, then it either overestimate, it can increase your estimate, it can give you underestimate of your result. So, for example, you do the case control study and you want to see the association between smoking and the lung cancer, then of course you should try that age factor or gender should be equally distributed between two groups. That you do with the help of the matching. Similarly, in the experimental study, you also try that stage of disease should be equally distributed between study groups and the experimental groups. That you do with the help of the randomization. So confounding factors, if you do not take care of the confounding factors, then your results may be distorted. For example, here you want to see relationship between the low level of mother's education and malnutrition under 5s. Family income may be related to the mother's education as well as in malnutrition. So it is influencing both. We all know that poor families have more malnourished children. Similarly, it also affects the mother's education. If the family income is low, sometimes mothers are not very educated. So it is influencing both. So in that, you have to take care of this. Family income should be equally distributed between the control and cases. Now, what is the data? Collection of observation in a scientific way is called data. Now, data is basically two types, categorical or qualitative. Nowadays, they don't call qualitative because there is qualitative research also. So it is better you call it categorical data and the numerical data. Numerical data is further of two types, discrete data and continuous data. Now, categorical data means you can categorize your data, your variables. You cannot measure it. You can all make categories. It is further of two types. For example, are you hearing my voice?
Yes, sir.
Okay, sir. Okay, thank you.
Yes, sir.
Yes, sir.
Okay, thank you very much. Data is mainly of two types. That is very important to understand, because all further your analysis, descriptive analysis, graphs, mean, median, mode, standard deviation, percentages, test of significance, chi-square test, all depend upon the type. If you know type of data, type of variable in your study, then you can easily apply those tests and you can make those graphs. Basically, data is of two types: categorical data, which can only be categorized. You cannot measure it. It is further of two types: nominal data and ordinal data. Nominal data just have names. It has no order. For example, gender may be male, female. Blood group may be A, O, AB. There is no order in it. Similarly, marital state may be marital status may be single, married, divorced. There is no order in it. Whereas ordinal data, it has order in it. For example, stages of disease may be first, second, third stage of disease. Similarly, degree of pain may be mild, moderate, severe. When there is order, it is called ordinal data. So these are two types of the categorical data. Then second type is numerical or quantitative data. In numerical data, there are further two types: discrete and continuous. Discrete data is in whole numbers. It cannot be in decimals. For example, number of students in the class, number of patients in the hospital, number of measles cases. They cannot be 5.6 or 5.7 or 8.10. It cannot be in decimal. It is always in the whole numbers. So second type of numerical data is continuous data. Continuous data on a continuous scale. It may be in decimals also. For example, height, weight, blood pressure, serum cholesterol, blood glucose level, BMI. All these are on continuous scale. So it can be even decimals. So this is very important to understand, because further analysis in your study depends if you know that which type of data, which type of variable is in your study, whether it's categorical or numerical, and if it is categorical, whether it is nominal or ordinal, and whether it is if it is numerical or quantitative, it is discrete or continuous. So it is very important to understand this. So what you can count is discrete, what you can measure is continuous. That is a rule of thumb. You can also convert it into study variable from continuous to categorical variable. You can convert it. There is the option in the SPSS by cutoff points. For example, blood pressure is a continuous variable. But if you want to convert it into the categorical variable, you can make category. For example, hypertension, you can define diastolic blood pressure greater than 90, you can say hypertensive, and normotension, blood pressure less than 90, you can say normotension. So you can convert. Similarly, height can be converted. It is a continuous variable. You can convert. There is the option in the SPSS, recode into different variable. You can convert into short, average. Then it becomes categorical. Now, these measurement scales are often used as an SPSS. Once you enter the data in SPSS, you define your variables. And while defining the variable, it also asks the scales of measurement, whether nominal scale, ordinal scale, or ratio or interval. Nominal scale, as we know, just names, no order. Ordinal is scale is there is order, there is rank. Both are types of the categorical variable, categorical data. Ratio is a special kind of interval scale in which two 0 points exist. For example, temperature. Zero temperature does not mean the absence of the temperature. Similarly, 60 degrees centigrade temperature is not twice as hot as 30 degrees. So zero is present there. in interval, 0 is absent. For example, height or blood pressure. If the 0 blood pressure, it means absence of blood pressure. So both these nominal scales, male, female, severity of pain, they are type of categorical data. Interval and ratio scales, they both be categorized as numerical data or continuous data. Why do we collect data? Monitor progress in our programs, get information, identify gaps between knowledge and practice. You do knowledge, attitude, and practice gap studies, making decisions. You cannot make any decision whether you are clinicians, whether you are health investigators, you need some data. Similarly, planning cannot be carried out without the data. Now, statistical analysis is basically of two types: descriptive statistics and inferential statistics. In descriptive statistics, you use to observe and present general trend and finding of the data. Only visual relationship and frequencies are mostly seen and reported as it is. Descriptive statistics cannot provide general. You can't generalize your results from the sample to the population. That we do in the inferential statistics. In this, you mean, median, mode, percentage of frequencies you calculate, and similarly, in case of categorical data, you calculate mean frequencies and the percentages, and the continuous data, you calculate mean, median. Similarly, graphical display for categorical data, you make the pie chart, bar chart, and for continuous data, quantitative data, you make the histogram, frequency polygon, scatter diagram. So we will discuss one by one. Descriptive statistics, collection of data, survey. For example, you want to carry out what is the prevalence of the hypertension, diabetes in community. So you can carry out a survey. This is again a descriptive statistics. You can present the data in the form of tables, graphs. You can summarize data. All this is descriptive statistics. Descriptive statistics, for example, once you write a synopsis, you have to give the statistical analysis. So what type of analysis will you do? You can, if you not can give, if you cannot give in detail, you can give that descriptive statistical analysis of continuous and categorical variable B will be performed. Data on continuous variable will be presented as mean and standard deviation. Of course, you can calculate mean. For categorical, you cannot calculate the mean of the gender. You cannot calculate the mean of blood pressure. Blood groups. So that are presented in the form of percentages and the frequencies. Here, for continuous data, you can calculate mean, standard deviation, and so you. Some people use mean plus minus. Wherever you give mean in your, for example, you say mean age, your study participant this, you always give along with the standard deviation. That is important. Plus minus standard deviation. So you do not give mean plus minus standard deviation. That is not mean. Standard deviation is used not for dispersion of data in your study. It is used. It tells the percent of your study, how close your sample estimate is to the actual population estimate. Inferential statistics, here you draw conclusion based on the sample you apply to the general population. So in this, you use the various tests of significance, and chi-square test, t-test, ANOVA, and you calculate the p-values for testing the hypothesis. You can also calculate, now there is a trend also I told earlier, that along with the p-value, must also give confidence interval, because p-value only tells the significance of association between two factors, significance of difference between two groups. It does not tell the effect size, clinical significance. So clinical significance is very important for clinicians. So that at confidence interval will tell you the effect size also. So both are nowadays required in your. Once you apply the chi-square test or t-test or test of significance in the SPSS, confidence interval is automatically calculated. Inshallah, we will discuss into tomorrow's SPSS programs once we will hands on SPSS. Now, how will you present the data? You can present the data in the form of tables, graphs, or that is the graphical methods, or you can present in the form of summary measures, mean, median, mode, standard deviation, etc. So numerical methods, mean, median, mode, standard deviation for quantitative data, and frequency percentage for categorical data. Tables and graphical methods, histogram, scatter diagram, frequency polygon you can use for quantitative data, and bar chart and pie chart for qualitative or categorical data. So what is table? Table is a systematic presentation of data classified into suitable heads and subheads and placed in columns and rows. This sort of a logical arrangement makes the data easy to understand, facilitates comparison, and provides effective way to convey information to the reader. So once you have more data, it is better to present it in the table. Now there are certain rules. Once you make table in your research, so there are certain rules you must follow. The table should be numbered, table 1, table 2, consecutively in your research articles, and a title must be given to each table, and you must also give heading and caption to each column and row. Subtotal and total of items of table must be given. Body contain numerical values in actual numbers and percentages or both. Table should not be too large. Too much data should not be given table. That also irritates the reviewer. It should be self-explanatory, and you should give footnotes in the table, standard code symbol which you used in the table. You should explain in the footnote. Similarly, data source. If your table is not original, you must give it a source also. So no cell should be left blank. Write nil if frequency of that group is 0. So that are certain rules which you must follow. So text tells the story, table provide the evidence, and graph illustrate the results. Avoid unnecessary repetition of data. If you make a table of some data, do not make the graph. That is a redundancy of data. Don't do that. Either you make the table, either you present the data in the form of table, otherwise graph. But do not make of the same data table and graph. That is not permitted. This is a table, age distribution of patient, just one-way table. Such type of table you have often seen. This is again a one-way table, various days and frequency. Once you give these frequency, you must give percentage also. You can make separate column of percent, or you can give here in the bracket also. Both are acceptable. This is a two-way table where you want to see the association between gender and race. You will make two-way table. Computer SPS will make it for you, so there's no need of worry. If you want to see association between hypertension, coronary heart disease, similarly two-way table. But in the table, you must once you enter the data variable in the SPSS, you must remember that this risk factor, that must be in the rows column. They must be in the rows. Whereas the disease that our outcome, you must place in the columns. So that is important. Graph must represent a summary of data that has been collected to support the particle theory. It is usually suggested that the graph representation of data should be assessed before proceeding, because graph tells you many things, whether especially histogram tells you whether your data is normally distributed or not. And depending upon your distribution, then you apply the test of significance. A parametric test, chi-square test, t-test, or ANOVA, or you want to apply non-parametric test if your data is not normally distributed. So before proceeding statistical analysis, you must make graph of your data. You must present your data in the form of graphs. So graphs have a powerful impact on the imagination of people. We all know diagrams are better retained in memory. It is often said that a picture is worth than 1,000 words. Now, common use of graphs, visual presentation, good to understand, attractive, to check assumptions, whether data is normally distributed, whether your data is asymmetrical, skewed distributed. And it also has been selection of statistical tool further analysis. So general use of designing graph should be self-explanatory legend and should help the reader to understand data. Axis must be labeled properly. Unit of measurement must be indicated. Very important. Now, these are common types of graphs which we use in our research. Pie diagram, simple bar diagram, multiple diagram, multiple bar diagram, subdivided bar chart, histogram, scatter plot, box plot. We can see one by one. Now, the pie chart is used in the categorical data. When your data is category, for example, gender or marital status or blood group, etc. You use the pie diagram, you make the pie diagram in the categorical data, not in quantitative data. You make pie chart when categories are less, maximum 5, maximum 6, not more than. If you make there are 10, 11 categories in your variable, then don't make pie chart, because it will be difficult to read. The slices will be very small. It will be very difficult to read the slices. Then you make the bar chart. This is again presentation occupation data in the form. This is again a simple bar chart of the 9 different age groups. Then this is a bar chart showing method delivery of 600 babies born in hospital, C-section, forceps, normal delivery, of course more, but nowadays the trend of C-section is also going up. This is a little bit old graph. Now, multiple bar chart you make when you want to see the relationship or association between 2 variables, categorical variables. He has compared the 2 cities in Zafrabad and Mansehra. You can make graphs side by side, or you can make subdivided bar chart one upon the other. That is the same thing. It's up to you. Histogram you make in continuous data, height, weight, blood pressure, etc., age, and it is very important. It tells you the behavior of data, or pattern of data, pattern of distribution. Whether your data is, it is one way of testing the normality of data. There are of course other tests also. Histogram you make in the continuous data. If this is a curve, this is normal curve, smooth bell-shaped curve. If this curve, it is your histogram like this, it means it's a normally distributed. Normal, it is no symmetrical distribution. It gives you the mean, standard deviation. For understanding the normality of data, histogram is very, very important. So mean, median, mode, and the normal distribution lie in the center. 50% value above, 50% value below. And skewed distribution, when your data is not normally distributed, it may be positively skewed, it may be negatively skewed. Positively skewed, right tail is longer than the lower tail. Sometimes in your data, there are some extreme values, 1 or 2 extreme values. For example, income, you collect the income of the 100 people. You may have 90 people income very close. There may be 10 people which have very high income. And when you calculate mean, it is not truly representing mean of that group. Mean may be very high. So it is positively skewed. It means mean will be higher, median will be low, mode will be even less. So you must understand according what is the distribution of each data. This is a normal distribution. In normal distribution, mean, median, mode will be. If there is a difference between mean, median, mode, the data is not normally distributed. Similarly, a negatively skewed, this normally lower tail is longer than the upper tail. Here sometimes in your data, some 1 or 2 values they come very low, which make your data negatively skewed. More frequency on the other side, but less frequency here, for example, period of gestation. Now, scatter plot we make in continuous data when we want to check the association or relationship between 2 continuous variables. 2 continuous variables, then association you want to check, you make the scatter plot. For example, you want to see the relationship between the weight after treatment, weight before treatment, or you can check the relationship between height and weight, between cigarette smoking and life expectancy. So you can make the scatter diagram. It will, if the one thing is increasing, other is it positive correlation. If the one thing is increasing, other is decreasing, it is negative correlation. For example, smoking and lung cancer, positive correlation. Smoking and lung, life expectancy, a negative correlation. Of course, when smoking will increase, life expectancy will decrease. Similarly, the number of days attended student attended the class and they are grade in the class, that is again also positively associated, positive correlation. Similarly, you can see current salary, education, or the current, both are increasing. If you have a higher education level, of course, your current salary will also be high. This box and whisker plot is used in continuous data when you want to see the outliers, extreme value in your study. This is also important. You should you see the behavior of data or outliers in the, or in your data, and it gives 5 measures, summary measures. This is the lower minimum. This is maximum value. Then this is the Q1, the where below which 25% observation lies. This is median. This is the Q3, below which 75% observation lies. So this is the 50% of data, your data lies here. This is outlier. Outlier, if your studies are, you have to sort out why this outlier has come. R values are close, one value is very high. It may be typing mistake. It may be participants intentionally has entered the some wrong figure. So you have to take care this outlier before you carry your analysis. Otherwise, it will disturb your analysis. So SPS, inshallah, will discuss tomorrow. In SPS commands, you go into the graphs and then legacy dialog, and this window will open. Then in this, you can make bar chart, can make pie chart, you can make box plot, you can make scatter, histogram, etc. Any graph, you can just one click, you can make it. Now this is important. You can take a screenshot of this. This is summary of the whole, very important. You can take a screenshot of this table. If you have a categorical data and ideally less category, not more than 5 and 6, you make pie chart. If your data is categorical and ideally when more categories, then you make the bar chart. If your data is categorical with multiple way, you want to see the association, then you make the multiple bar chart or subdivided bar chart. For quantitative data, especially for continuous data, height, weight, blood pressure, you make the histogram. If you want to see the relationship between two quantitative variables, linear relationship, you calculate the scatter diagram, which will tell you the linear correlation. Then if you want to see the outliers, extreme values in your data, in case of quantitative data, you make the box plot. So measure of center tendency. Once you collect the data, 3 questions arise after the data are collected and presented. What is the average or central value? You want to see what is the average or central value of your series. How are the other values dispersed, scattered around the center value with the help of the standard deviation. And then you want to see the shape of distribution. Often searches come to me that we want to check whether our data is normally distributed or not normally distributed. It is very easy in case of continuous data. You can check it with the help of histogram. You can check with the help of this is the Kolmogorov-Samarkov test and Shapiro test. These tests are given in SPSS, and just one click you can check normality of data. Inshallah, tomorrow we will have a look on this also. The single number that summarizes the distribution more concisely, that is called the measure of center tendency, where the center ends. You want to see where the center ends, where the middle of bunch of data lies, that is called measure of center tendency. It can be, you can do that with the help of 3. Either you can calculate mean, simple average, tells about the center trend. You can calculate median, it is the most middle value of the data. Mode is most frequent value of your data. So suppose we have the ages of students like this. Now mean is this 25.3, median 23. They are very close. Mode is 23. Normally they should be close if the data is normally distributed. The mean computer will calculate adding all value divided by number of observations. This is a middle value after arranging the data. This is the most frequent value of your data. Or computer will calculate, SPS will calculate it for you. So no need to memorize the formulas. Now problem with the mean is that is unduly influenced by the extreme values. That is the main problem. So it distort our perception about the center tendency of the measured value. So if there is a mean in your, if some extreme value comes in your data, then your mean does not become realistic. It is not realistic. For example, this is the income of 7 people per day in rupees. Now all 6 people have income very close. One has high, 102. Due to this, mean has become 22. Now all 6 values are below this, and just one value above it. So this is not representative. In this, when there are extreme values in your data, it is better to calculate median. Median is 7, which is very representative. Half values almost above, half values below. In that case, when there are, median is not affected by extreme value, mean is affected by extreme value. So sometimes also it looks ridiculous, comes in fractions in case of median number of children. So there are problems. In that case, you calculate mean. For example, here you say mean and median should be close. They are close here, but once the extreme value comes here, then they are not close. Median is not affected by extreme value. That in skewed distribution, when the distribution not normal, like income, median proved to better estimate than the mean because not affected by the extreme values. Also used in ordinal data, categorical ordinal data, median can be used. Now, general principle of measure of center tendency in symmetrical distribution, mean, median, modes are identical. A better way of representing data is to use two summary measures, one to indicate center tendency and one to indicate variation. The most commonly used pair is the arithmetic mean and standard deviation. Once you write mean in your article, in your research, you always write along with standard deviation. You can write in this way, mean plus minus standard deviation, or you can write like this, mean in bracket standard deviation. The mean is used for numerical data and for symmetrical distribution. Median is used for ordinal data or numerical data if the distribution is skewed. Mode is primarily used for category most frequently occurring value in the in your data that is normally used in nominal categorical data. For example, most common disease or most common eye color or most common size. It is used also business sector. The most common size of the caps or shoes which is being used by the people, they procure. In business sector, mean is not very much used in medical analysis. So this chapter, this table is also important. You can take the picture of this, that if your data is nominal, categorical nominal, you make proportion, frequency table, percentages, and mode. If ordinal, same. If discrete, same. If your data is continuous, mean and median. Median when you have extreme values, outliers in your data. Measures of dispersion mainly are two types: absolute measure, which see the variability of data. To compare the variability of different groups with same units of measurements, you can use range, variance, standard deviation. Commonly, standard deviation, range are used. Relative measures to compare the different groups with the different units of measurement. When the unit of measurements are different, for example, one group weight is measured in the pounds and other is the in kg, you want to see which group have the greater variation. So this will give you the in percentage, it's independent of unit of measurement. In that case, you can use also coefficient of variation. So this is a scattered data, and then collect the mean of all the deviation, and then the mean. Why measure of dispersion? If you have the ages of children, for example, this, their mean is 7. If the ages are this, their mean is again 7. Now, how will I know, how will I come to know that which data has greater dispersion, which data is not good for me, which has more dispersion, more scattered. So this is not, I will have to calculate standard deviation. So standard deviation, the average variability of data from a center, variance square root of standard deviation. Why measure dispersion is important? For example, ages here, 7, both have same mean. Standard deviation here is 3.1. 2. Here is standard deviation 5.6. It means this data is not ideal for me. It has more dispersion. This data is less standard deviation, less dispersion. This is more suitable, more ideal for me. Range is difference between maximum and minimum values. Standard error is how precisely the population mean is estimated by the sample mean. So that depends upon how much variation there in the population on the size of the sample. Larger the sample, the smaller will be the sample. The smaller standard error in your data means your study is more precise, more valid. So if you have large sample size, of course, the standard deviation is this is standard error mean is standard deviation divided by n under root. This is the formula of standard deviation divided by n under root. So if you have large sample, standard error will be small. Your study will be more precise. Approximately 95% sample mean obtained by repeated sampling would lie within 2 standard error above or below the mean. This fact can be used to construct a range of likely values for the unknown population mean. It is standard error. Such a range is called the confidence interval. Confidence interval we will also discuss inshallah. Coefficient variation, this is a ratio of the standard deviation to the mean multiply 100. It is independent of units of measurement. It gives the dispersion in 2 sets of data. When there are standard deviation may be same, may give fallacious results. So then you apply the coefficient of variation. Interquartile range is the range of covering 25% measurements on either side of the median. The difference between first and third quartile, it is called the interquartile range. Between 25th and 75th percentile, as you have seen box and whisker plot. This covers the range 50% middle observation in the group. So use of different measure of dispersion, standard deviation used when the mean is used with symmetric data is symmetrical numerical. Interquartile range you use along with median when the data is ordinal at skewed numerical and it is skewedly distributed. Interquartile range used by the 50% distribution. Range is used when numerical data when the purpose is to emphasize extreme values. Coefficient variation used when intent is to compare the distribution measure on different scales. So using SPSS for descriptive stat, tomorrow inshallah we will have hands-on SPSS also. You go and menu and dialog box, analyze, select analyze, descriptive statistics, then frequencies, then it will open this. In this you can calculate mean, median, mode, standard deviation, minimum value, maximum, just with one click. Now we have done with descriptive statistics. Now we discuss the testing of hypothesis or inferential statistics, where you calculate p-values or confidence interval, and you apply your results of sample. You generalize your results drawn from the sample to the population. So hypothesis testing is the imperative phase of statistical inference. It is a procedure that enables us to decide upon the basic information obtained from the sample data, whether to accept or reject the statement or an assumption about the value of population parameter. So there are 2 types normally hypothesis, null hypothesis. It is any hypothesis which is to be tested for possible rejection under the assumption that it's true. It usually contains the term no effects, no association between no effect of both treatment. There's no difference in effect of treatments, and no difference between no association. This is null hypothesis. Normally in our study, we make the null hypothesis. As in Kalma, la ilaha illallah, we start with no, la, nahi. Here also, we start with null hypothesis. The difference between two, we assume that then we use, by using the test of significance, we can either reject or accept it. Null hypothesis assumption that in the total population, no real difference exists between groups, that no real association exists between the, that is why it is called null. It is generated 180-degree opposite to the question in hand in test of significance. Alternate hypothesis, it shows that there is the effect, there is a difference. For example, you can say mean IQ score of 2 study groups is different. So these are steps in hypothesis testing. You can formulate hypothesis, then you specify the level of significance, alpha level, select the appropriate statistical test, chi-square t-test, and then compute the value of statistical test with the help of computer. Then it will calculate the p-value. Then basing on the p-value, if it is less than 0.05, you reject the null hypothesis. If it is more than 0.05, you accept the null hypothesis. The level of significance is the probability of rejecting the null hypothesis if it is true. It is usually denoted by alpha or type 1 error. So normally the most frequent used value of alpha or level of significance set either 0.05, 0.01 or 0.05. Normally we select the 0.05 that if your p-value is less than 0.05, 0.05 or less than 0.05, we will reject the null hypothesis. So in genetic study, sometimes you need more precision, and you can see that if the p-value is 0.05, 1% or less, then you will reject the null hypothesis. So it is in simple words, what is p-value? This is the probability of occurrence of result by chance. That is the chance, the difference association which you have observed in your study, that by chance that difference which you have come, whether it's 4%, 5%, 7% p-value, so that difference is, but 5 up to 5% is acceptable chance in your study. But of course, in 5% you have made a mistake, and you have wrongly rejected the null hypothesis. Null hypothesis say no difference, and you say there is difference. You have made association, you have made a difference when there is no difference. But in 5% cases is okay. But as you reduce the chance in your study, 4%, 3%, your study will be more valid. So we reject the null hypothesis p-value less or equal to, then select whichever you select. We reject alternative hypothesis except null hypothesis if p-value is greater than selected alpha. So p-value is, if the p-value is low, conventionally it is less than 0.05, the null hypothesis no association rejected. Chance is considered as unlikely explanation for the finding, and the results are considered as statistically significant at that level. So if the p-value is less than 0.5, you must be happy. If it is more than 0.05, game is over, then try again. So this is insignificant results are also equally important. They must be reported also. You should not pressurize the statistician or somebody expert in data analysis that you make your p-value less than. One can make that p-value less than by manipulation of data, but that should not do. So if your null hypothesis is true and you accept correct decision, but if you reject it, null hypothesis, there is no difference, no association, but you make difference. It is type 1 error. It is a wrong decision, type 1 error or alpha error. If null hypothesis is false and you accept the null hypothesis, false null, it is a type 2 error, wrong decision. Difference is there, but you were unable, null hypothesis say there is no difference, but you accept it. Yes, you also say there is no difference, no association, but you were unable to detect so you make a type 2 error. So this is the, during a trial, null hypothesis, man is innocent. And if we execute him and he was innocent, you make it. It is big blunder. It is big. It is more serious error. Type 1 error is more serious error. That person is innocent and you execute him. But alternate hypothesis may be man is criminal and we release a man. There was no evidence and he was criminal. You make a type 2 error. So this is not more serious. The common statistical test which we use in our research are 70% test almost, t-test and chi-square test and ANOVA. And chi-square test we used in the categorical data to compare the categories, and if in the continuous data, quantitative data, we want to compare the means, we use the t-test. For two means, comparing of two means, t-test. For comparing of more than two means, we use the ANOVA. These are less commonly used non-parametric tests. Normally, if your data is not normally distributed, of course, then we use the these tests. Fisher exact test used in place of the chi-square test if the sample size is less than 20 or between 20 or 40, smallest expected value of any cell is less than. Wilcoxon test we use equivalent to PAT test. Spearman-Rank correlation, then Mann-Whitney use test used equivalent to two sample t-test. Kruskal-Wallis test in place of ANOVA test. That these are less powerful tests. They are sometimes used when the distribution is not normal. Your data is not normally distributed. So choice of statistical test, which test will you select? That will depend upon the type of data. If the data, whether data is numerical, you will select t-test or p-t-test, independent sample test, ANOVA, etc. If it is categorical, then normally you select the chi-square test. In case of numerical data, how data is distributed? Normally distributed or there is skew distribution. If the data is normally distributed, you will apply parametric test, chi-square test, t-test, ANOVA test, etc. Regression, correlation. But if it is skew distribution, then you will apply naturally Mann-Whitney use test, Fisher exact test, Wilcoxon test, etc. Then it also depends on the type of sample, whether groups are independent or not. Paired observation or repeated measurements are independent groups. So if they are paired observation, same group, before after comparison you want to carry out, you will apply paired t-test. Question to be answered, number of groups being compared. Difference between two groups, you want to mean difference between two groups, you will apply t-test. If you want to compare mean of two groups, you will apply ANOVA test. So it all depends. So test of significance, chi-square test along with p-value must be, once you give in your results, result section, the p-value must also give the value of chi-square t-test below the table. Results should also be presented in the form of p-value. Confidence interval are now, I say, very important. Most of the editors, they ask, most of the reviewers, they ask that confidence interval, because they give the effect size, that must also be mentioned along with the p-value. So student test, t-test, PIT test, ANOVA, when you compare the observation twice of the same group, before after comparison. Group is same, we take compare the observation twice. That is, we apply the PIT test. Effect of, for example, Panadol in pain relief before and after. Effect of the teaching method before and after. You want to see effect of teaching method. Then effect of anesthesia on blood pressure twice. Group is the same. Then you apply the PIT test. Similarly, assumption underlying paired sample t-test, the data must be continuous and it should be normally distributed. Independent sample test we apply when we want to compare the means of the two groups, two independent groups. So, for example, you want to compare the average weight of male and female students, size of the benign and malignant tumors, sleeping time in neurotic and psychotic patient. You will apply the independent sample t-test. Assumptions are again same, data must be continuous, normally distributed, and groups must be independent. Analysis of variance we apply when you want to compare the means of more than two groups, 3 or 4 or more. So data should be continuous, normally distributed, and groups must be independent. Repeated measures of ANOVA, when we take measurements more than 2 times from the same subjects, we apply repeated measurement of ANOVA. Suppose we take blood pressure on different unit times, say 5 times after giving treatment, we apply the repeated measurement of ANOVA. Assumptions are same as paired sample t-test. So this you can take a picture of a screenshot of this table. Very important, this table also, that if your data is quantitative and we want to compare the average of 2 independent groups, you will apply independent sample t-test. And similarly, if data is quantitative, you want to compare mean of the more than 2 groups, you will apply ANOVA. And similarly, if your data is quantitative, you want to compare 2 information of data taken from the same groups before and after comparison, that is, you will apply paired sample t-test. And if your data is quantitative, you want to compare more than 2 information taken from the same groups, then you will apply repeated measurements. Chi-square test use this is a formula you need not to memorize. Computer will SPS will calculate for you. This is normally you must only understand chi-square test you apply in categorical data to compare the proportions. So SPS will use this is a table like this. Validity of chi-square test is that sample size should be more than 40, or between 20 and 40. Smallest observation should be, expected value should be at least 5. Then you can. In other case, if the sample is less than 20, you should apply Fisher exact test. Now 95% confidence interval is also very important. If you can also calculate significance of your result from the 95% confidence interval, even if you do not calculate the p-value. For example, if the 90% confidence interval you calculate of the odd ratio in case of case control study, or the relative risk in case of the cohort study, then if the one comes in between the confidence interval, then it means your confidence interval, these results are not statistically significant. Similarly, when there is overlapping confidence interval of two groups, there is no significant difference between those, like means or proportion, etc. Similarly, if you can't, for example, 95, you calculate 95% confidence interval relative risk, and it goes from 0.8 to 2.5. It means it contains 1 in the interval, so therefore not significant. Similarly, if 95% confidence interval difference between two means contains 0, for example, it starts, lower limit start from minus 1.5. Confidence interval is always in with two figures. Minus 1.5, 3. It contains 0. So results are not statistically significant. So statistical significance versus effect size or clinical significance. P-value summarizes significance. It does not mean that results are clinically significant also. P-value does not tell us anything about the magnitude of difference between two treatments. For this, we need to calculate the confidence interval. So nowadays, that is why confidence interval is very, very important. Along with p-value, must give the confidence interval in your research articles. Now, approximately half of the article published, this study was carried out in the United States a couple of years back, and they found that approximately half of the article published in the medical journal that use statistical method use them incorrectly. Simple mistakes such as neglecting to include control group, not allocating treatment subjects at random, or misusing elementary statistical hypotheses such as standard deviation, standard error, t-test, etc. Journal should score review by some knowledgeable in statistics before accepting a manuscript. In addition, research committees, institutional review board should insist that investigators define an appropriate strategy for data analysis before approving a protocol. What difference it makes if you apply wrong test, wrong statistical analysis? There may be indirect cost. These are may lead investigator to report a statement, treatment, or diagnostic test to be of statistically demonstrated value. In fact, the data do not support this conclusion. People treated on the basis of erroneous research reports gain no benefit, even may be harmed. And direct cost may be money is spent, animals may be sacrificed, human subject may be at risk to collect data that are not correctly interpreted. So rules of thumb to spot potential errors. Difference, you must know the difference between when you should use standard error, when you should use the standard deviation. You should know the meaning of p-value, common errors in the use of t-test, and the how to compensate for them. Standard error, as we have already discussed, express the variation of sample mean around a parent population. For example, you collect a sample of 10 students from a class and you calculate mean of that 10 students. Then you calculate the mean of the whole class, whole population. That definitely there will be different based on the sample mean and the population mean, and how big is the difference. This depends upon the sample size. If you increase the sample size, the difference will be. The more close you are sample estimate with the population, less is the standard error. It will your study will be more precise. So standard error mean quantified degree to which sample mean estimate the population. Mean it does not tell you the dispersion of data. So you don't use standard error mean along with the mean. So formula standard deviation under rule. Standard error mean does not quantify the variability in observation as the standard deviation does, but rather the precision with which sample mean estimate the two population mean. Thus, standard deviation, not the standard error mean, should be used to summarize data. Remember this. Now, why do most authors use the standard error of mean to summarize the data? By tradition. A standard error mean is smaller than the standard deviation, always smaller. Meaning of p-value or significance level, probability of difference by chance, when in reality there is no difference between two groups or treatment, erroneously concluding that treatment had effect when in reality it did not. So common errors in the use of t-test also people make. They use the t-test for difference among more than two groups by comparing all possible pairs of means. For example, there are four groups. You are comparing means of four groups. First, they will compare first two groups with t-test, independent sample, and then they will compare other two groups with independent sample. That is wrong. T-test should only be used to test null hypothesis when there are two groups. When null hypothesis, the two groups are not different. For comparing more than means of more than two groups, 3 or 4, ANOVA should be used, not the t-test. So how can these errors be prevented? First, journal editors should insist that statistical methods be used correctly. Second, research committees and institutional review boards should not approve experiments on humans if the proposed study is poorly designed or resulting data will not be analyzed correctly. Rejection of the paper or protocol should motivate investigators to acquire an understanding of elementary statistics. That is very important. That is why this webinar was organized. So you must have at least understanding of the elementary statistics before you carry out a search on some topic. So biostatics plays pivotal role in biomedical research and helps take important preventive therapeutic or diagnostic decision. Biostatics is comprehensive, intricate, advanced field that needs proper learning before conducting any research. For any research to accomplish precisely, consultation of persons having expertise in biostatics should be considered. So thank you very much. That's all for today's webinar. Now, if you have any questions, you are most welcome.
Assalamu alaikum, sir. I'm Dr. Huma Saeed from the Physiology Department. Sir, can you hear me?
Yes, I am here.
सर मेरा क्वेश्चन था पाई चार्ट्स के मुतालिक। अक्सर मैंने पाई चार्ट्स में ऐसी कैटेगरीज देखी हैं कि आप 3 या 4 कैटेगरीज तो प्रॉपर्ली बना लेते हैं, उसके बाद बाकी जितना कुछ बचता है उस सारे को मिसलेनियस के अंडर डाल के तो पाई चार्ट में इंसर्ट कर देते हैं। मैनी अ टाइम्स मिसलेनियस हैज अ ग्रेटर in the pie chart than rest of the categories. Is this right?
No, this is not right. Normally, if the categories are more, for example 9, 10 or 8, फिर आप उस सूरत में बेहतर है आप बार चार्ट बना लें। बार चार्ट इज आल्सो फॉर कैटेगरिकल डाटा। इट इज नॉट सच कि आपने हर केस में पाई चार्ट ही बनाना है। पाई चार्ट इज फॉर लेस कैटेगरीज व्हेन यू कैन रीड दी, यू शुड नॉट कंबाइन। इट इज बेटर मिसलेनियस की बजाय आप सारे बनाएं, आप उसको बार चार्ट बना दें।
Thank you very much, sir. Thank you.
Any other question?
Thank you so much, Professor Ashraf. Thank you so much for this very nice webinar.
Thank you.
Can you kindly throw some more light on the standard error of mean?
Standard error mean, I have told that standard error mean formula standard deviation divided by n. It is inversely proportional to the sample size. The larger the sample size, standard error उतनी कम आएगी, ठीक है ना। Standard error जो हम वेरिएशन के लिए डिस्पर्शन ऑफ डेटा के लिए यूज नहीं करते। We only use standard error to find out how actually your sample is representative of your population. Population जो ट्रू पॉपुलेशन, नेचुरली आप अपनी स्टडी में सैंपल लेते हैं और उसी से आप कैलकुलेट करते हैं, और जो सारी पॉपुलेशन स्टडी तो नहीं कर सकते, लेकिन अगर वो सैंपल जो अगर जितनी स्मॉलर होगी इतना ही आपका जो सैंपल एस्टिमेट है, इट विल बी मोर क्लोज टू दी योर पॉपुलेशन, which is more, it tells all the precision of your study. Your precision of study will increase. Normally use, कुछ रिसर्चर करते हैं स्टैंडर्ड डेविएशन प्लस माइनस, मीन प्लस माइनस स्टैंडर्ड, that is wrong. That is not used for dispersion. For dispersion of data, see the dispersion, कितनी डिस्पर्शन है डेटा के अंदर वैल्यूज के अंदर, तो वो उसके लिए मीन स्टैंडर्ड डेविएशन दी आइडियल। स्टैंडर्ड एरर इस मकसद के लिए यूज नहीं होती। अक्सर ये लोग यूज करते हैं बाय ट्रेडिशन, या क्योंकि ये स्मॉलर होती है, पीपल डू नॉट वांट कि उनके डाटा में ज्यादा स्केटरिंग है, ज्यादा डिस्पर्शन है, ज्यादा आइडियल नहीं। तो ये है मेन डिफरेंस।
अस्सलाम वालेकुम सर।
जी
Thank you
वालेकुम।
so much. Thank you.
सर मैं पूछना चाहता हूँ,
जी
कॉन्फिडेंस इंटरवल, कॉन्फिडेंट इंटरवल जो है CI,
जी
इज इट एप्लीकेबल टू कंटिन्यूस डाटा जिसमें मीन और स्टैंडर्ड डेविएशन निकालनी हो, या ये काई स्क्वायर के लिए भी एप्लीकेबल होता है?
नहीं, ये दोनों में अप्लाइकेबल है। जब आप SPSS के अंदर काई स्क्वायर भी निकालते हैं तो काई स्क्वायर जो होता है कैटेगरिकल डेटा होता है, उसके अंदर नेचुरली आपका ऑड रेशो या रिलेटिव रिस्क आता है जो कि रिस्क की स्ट्रेंथ ऑफ रिस्क को बताता है, ठीक है ना। फॉर एग्जांपल अगर ऑड रेशो 2 है बिटवीन स्मोकिंग एंड लंग कैंसर, you say smokers are 2 times at higher risk of developing lung cancer as compared to non-smoker, ठीक है ना। तो वो कैटेगरिकल डेटा के अंदर भी वो जो आप ऑड रेशो होती है या कोहॉर्ट स्टडी के अंदर रिलेटिव रिस्क होता है, तो वो जो है उसका भी कॉन्फिडेंस ये निकालता है, आपका कंप्यूटर ही निकाल देता है अलॉन्ग विद पी वैल्यू। तो ये दोनों में यूज होता है। कॉन्फिडेंस आप रिलेटिव रिस्क में अगर निकालते हैं, केस कंट्रोल स्टडी है, कैटेगरिकल डेटा है, और उसमें या ऑड रेशो के लिए निकालते हैं, तो उसमें आपने फिर देखना है कि जो कॉन्फिडेंस इंटरवल की 2 लिमिट्स हैं उसके अंदर 1 तो नहीं आ रहा। अगर क्योंकि 1 ऑड रेशो या 1 रिलेटिव रिस्क, इट मीन नो एसोसिएशन बिटवीन रिस्क फैक्टर एंड डिजीज। सो अगर वो 1 आ रहा है तो नो, अगर 1 नहीं आ रहा इट मीन देयर इज स्टैटिस्टिकली सिग्निफिकेंट एसोसिएशन बिटवीन पी वैल्यू के साथ। ये कॉन्फिडेंस इंटरवल भी आपको एडिशनल इंफॉर्मेशन देता है। तो आजकल यही रिसर्च है कि आप जहां पर पी वैल्यू आपने टेस्ट ऑफ सिग्निफिकेंस से कैलकुलेट होती है वहां पर आप कॉन्फिडेंस इंटरवल भी मेंशन करिए। दोनों में आता है, कंटिन्यूस में भी है और दोनों में भी है। कॉन्फिडेंस इंटरवल जो कंटिन्यूस डेटा में है उसमें चूंकि मीन आप कंपेयर कर रहे होते हैं, तो उसके अंदर आपने ये देखना है कि जो 2 ग्रुप्स का मीन है उसके कॉन्फिडेंस इंटरवल जो आपने निकाला है उसके अंदर 0 तो नहीं आ रहा। 0 मीन नो डिफरेंस बिटवीन मीन। अगर 0 आ रहा है, उनकी 2 वैल्यूज के एक माइनस से शुरू हो रही है, एक ऊपर वाली प्लस है, तो नेली 0 इज कमिंग, तो इट यू कैन से दिस इज नॉट सिग्निफिकेंट। तो दोनों में ही यूज होता है कॉन्फिडेंस इंटरवल।
ठीक हो गया सर। तो ये जो रिलेटिव रिस्क है और जो केस कंट्रोल स्टडी है, ये एक स्पेसिफिक टाइप की स्टडीज हैं।
हाँ जी।
हम जो रूटीन में चेक करते हैं, जैसे मेल और फीमेल में हम हेपेटाइटिस बी की फ्रीक्वेंसी के दरमियान में हम काई स्क्वायर निकालते हैं, उसमें कॉन्फिडेंस इंटरवल कैसे आएगा?
नहीं, कॉन्फिडेंस इंटरवल आता है। कॉन्फिडेंस इंटरवल देखो जी वो साथ ही कैलकुलेट कर देता है। उसमें आप देखो जी आपको एडिशनल ये इफेक्ट साइज को बताता है कि हाउ जो आपका जो सैंपल एस्टिमेट है हाउ क्लोज इट टू दी पॉपुलेशन मीन। क्योंकि अगर वाइडर है कॉन्फिडेंस इंटरवल तो फिर नेचुरली वो लेस प्रिसाइज है। अगर आपका कॉन्फिडेंस इंटरवल नैरो आ रहा है तो इट मीन्स जो आपका सैंपल एस्टिमेट है इट इज मोर क्लोज टू द एक्चुअल ट्रू पॉपुलेशन। क्योंकि जब आप कोई भी निकालते हैं एस्टिमेट तो आपका सारी पॉपुलेशन का तो नहीं निकालता है ना, आप सिर्फ कॉन्फिडेंस इंटरवल आपको बताता है रेंज ऑफ वैल्यूज कि ये लोअर लिमिट। क्योंकि अगर 95% केस में भी आप रिपीटेड सैंपल लेते हैं, पूरी पॉपुलेशन से भी सैंपल लेते हैं, तो आपका जो मीन है या रिलेटिव इस रेंज से बाहर नहीं जाएगा। तो वो ज्यादा आजकल उसका ट्रेंड है कि इफेक्ट साइज को बताता है, जो आपके पी वैल्यू सिर्फ आपको सिग्निफिकेंस बताती है।
काफी कुछ समझ तो आ रही है। अगर आप मुनासिब समझे तो नेक्स्ट में जो कल होगा,
हाँ
उसमें कोई 2-3 स्लाइड में कोई एग्जांपल के साथ ना शुरू
हाँ
में
जी,
बता
वो
दें।
एग्जांपल के साथ ही होगा। उसमें हम इंशाल्लाह ये डिस्क्रिप्टिव स्टैटिस्टिक्स भी देखेंगे, और ये टेस्ट ऑफ सिग्निफिकेंस काई स्क्वायर है, टी टेस्ट है, पे टी टेस्ट है, अनोवा है, और कोरिलेशन रिग्रेशन वगैरह, ये सारे हम इंशाल्लाह देखेंगे 1 बाय 1 करके। बिल्कुल उससे 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 फिर आपको जो आउटपुट आएगी उसके अंदर उसको इंटरप्रेट करेंगे, उससे थिंग्स विल बिकम मोर क्लियर। ये जो कॉन्फिडेंस इंटरवल आप कह रहे हैं, क्योंकि जहां पर आपका पी वैल्यू आती है आपका टेस्ट, साथ ही वो आपका SPSS कॉन्फिडेंस इंटरवल भी देता है। तो कॉन्फिडेंस इंटरवल आजकल ज्यादा वो इस पे लोग टेस्ट कर रहे हैं, जो रिसर्चर्स हैं या पेपर व्यूअर्स हैं वो कहते हैं, या एडिटर्स हैं वो कहते हैं कि ये लाजमी होना चाहिए क्योंकि इट टेल्स द इफेक्ट साइज आल्सो।
थैंक यू सर।
हाँ जी, एनी अदर क्वेश्चन?
Sir, Assalamualaikum, sir, Dr. Iram. बायोकेमिस्ट्री। सर ये अगर हमारे जो हैं रिजल्ट्स के अंदर आउटलायर्स आए तो फिर हम उनके साथ क्या करें? उनको निकाल देना चाहिए या क्या करना
अगर
चाहिए?
आप इस रिजल्ट्स के अंदर आउटलायर इक्का दुक्का आ रहे हैं तो उसका तो कोई आप उसको निकाल के सूटेबल वैल्यू से रिप्लेस कर सकते हैं। फॉर एग्जांपल मे भी टाइपिंग मिस्टेक हो सकती है। फॉर एग्जांपल एज आपकी 60 20 30 40 आ रही है, एक एज 110 आ गई है तो आउटलायर है।
हाँ जी
110 आउटलायर है
जी
तो वो आपके डेटा को डिस्टर्ब कर देगी। तो वो उसका
जी जी
उसको फिर आप ये करें, उसको आप रिप्लेस कर सकते हैं। वो टाइपिंग एरर हो सकती है, या कई दफा कई सम पार्टिसिपेंट ऐसे इंटेंशनली भी वो उसको ऐसे लिख देते हैं ज्यादा वैल्यू, जैसे स्टूडेंट है इनमें टेंडेंसी होती है। लेकिन अगर ज्यादा आपकी वैल्यू फॉर एग्जांपल 5% के करीब आपकी आउटलायर्स आ गए हैं आपकी वैल्यूज के अंदर, फिर उसके लिए अदर टेक्निक्स हैं, वो ट्रांसफॉर्मेशन करते हैं, लॉग ट्रांसफॉर्मेशन। वो फिर डिफरेंट टेक्निक्स होती हैं, वो आप फिर उसका जरा थोड़ा लेंथी प्रोसीजर वो हो जाता है, वो भी हो जाता है, आप डाटा को ट्रांसफॉर्म कर। लेकिन अगर इक्का दुक्का वैल्यूज है तो आप जस्ट उसको रिप्लेस कर सकते हैं।
ठीक है सर, थैंक यू सर।
और जी कोई नहीं, एनी क्वेश्चन? प्रोफेसर नहीं, समीना नहीं, फिर इम्तियाज।
जी सर, मेरा एक क्वेश्चन है। हम डॉक्टर सायरा आतिफ।
जी
सर मुझे बताएं कि अगर हमारे डेटा में कोई आउटलायर्स आ रहे हैं तो आप क्या सजेस्ट करते हैं कि हम आउटलायर्स को कैसे हैंडल करें?
वही यही मैंने क्वेश्चन का भी जवाब दिया कि अगर तो आउटलायर आपके देखें जी, अगर जब आपके एक्सट्रीम वैल्यूज डेटा नॉर्मली डिस्ट्रीब्यूटेड नहीं है, वो तो है, उसके लिए तो फिर नेचुरली आप दूसरे टेस्ट ऑफ सिग्निफिकेंस यूज करते हैं, नॉन पैरामीट्रिक टेस्ट यूज करते हैं, या उसके अंदर मीडियन आप यूज करते हैं एज ए मेजर ऑफ सेंटर टेंडेंसी, और इंटर क्वार्टर रेंज करते हैं मेजर ऑफ डिस्पर्शन। लेकिन आपको हैंडल करने का तरीका मैंने यही बताया कि आउटलायर अगर इक्का दुक्का, आपको ये बॉक्स एंड विस्कर प्लॉट जो मैंने ड्रा किया था ये बता देगा। अगर इक्का दुक्का आउटलायर्स हैं तो वो तो आप रिप्लेस कर सकते हो। टाइपिंग मिस्टेक भी हो सकती है, वो इंटेंशनली भी सम पार्टिसिपेंट वो रॉन्ग फिगर एंटर कर देते हैं, वो तो कर सकते हैं। लेकिन अगर ज्यादा है फिर उसका अलग टेक्निक्स है, आपको लॉग ट्रांसफॉर्मेशन करनी पड़ती है डेटा की, वो भी हो जाता है, वो फिर उसकी अलग टेक्निक है।
ठीक है, थैंक यू सो मच।
हाँ जी, अनदर क्वेश्चन? तो सिंपल है, बेसिकली जो है जब भी आप स्टडी करें या डाटा एंट्री करें अपने एसपीएसएस के अंदर, डाटा एंट्री में तो नेचुरली आप फर्स्ट आप वेरिएबल को डिफाइन करते हैं कि वेरिएबल आपका किस क्वांटिटेटिव है या क्वालिटेटिव है, कैटेगरिकल है या कंटिन्यूस है, वट एवर। देन उसके बाद जब वेरिएबल डिफाइन हो गए हैं तो फिर आप अपना नेचुरली अपना डाटा एंट्री करते हैं, उसके बाद एनालिसिस करते हैं। तो वेरिएबल का अंडरस्टैंड करना, आपका डेटा किस किस्म का है, ऑल फर्दर एनालिसिस, वेदर इट डिस्क्रिप्टिव स्टैट एनालिसिस, whether it is a numerically display, whether it is graphical display, whether it is inferential statistics, all depends upon the type of, you must understand the type of data। कि डेटा जो है बेसिकली टू टाइप्स का है, वेरिएबल आप कह लें या डेटा कह लें, दे आर बेसिकली टू टाइप्स। वन इज द कैटेगरिकल डेटा which you can only categorize, you cannot measure it। मेल मैरिटल स्टेटस है या ब्लड ग्रुप्स है या जेंडर है। और इन अगेन इज टू टाइप्स, नॉमिनल है, ऑर्डिनल है। नॉमिनल में जस्ट नेम है, कोई ऑर्डर नहीं है। ऑर्डिनल है तो उसके अंदर ऑर्डर है, फर्स्ट सेकंड थर्ड है, स्टेजेस ऑफ डिजीज हैं, फर्स्ट सेकंड थर्ड है, सीवियरिटी ऑफ पेन है। सो उसके 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 अंदर ये जरूरी है, क्योंकि ये जब आप डाटा एंट्री करते हैं एसपीएस के अंदर तो वो स्केल्स में वो मेजरमेंट में एक कॉलम आता है, शुरू में वो पूछता है कि टाइप ऑफ वेरिएबल बताएं, तो उसमें न्यूमेरिक है या स्ट्रिंग है, स्ट्रिंग को कैटेगरी कहते हैं। तो वो जो है वो आपको यू हैव टू डिफाइन, और एंड पे वो स्केल पूछता है मेजरमेंट कि आपका वो ये नॉमिनल है, ऑर्डिनल है या स्केल है। स्केल मीन क्वांटिटेटिव। तो वो जब आप को ये क्लियर हो जाए कि डेटा टू टाइप्स का है, कैटेगरिकल है, नॉमिनल ऑर्डिनल है, और क्वांटिटेटिव या न्यूमेरिकल डेटा है, और जो कि मे बी डिस्क्रीट एंड कंटिन्यूस, डिस्क्रीट होल नंबर्स है, और कंटिन्यूस जो है ये ज्यादातर एज है, हाइट है, और कंटिन्यूस में भी है। तो वो कंटिन्यूस डेटा के नेचुरली डिस्क्रिप्टिव एनालिसिस भी अलग ही होगा। मीन मीडियन मोड को आप बनाएंगे, उसकी फ्रीक्वेंसी तो आप कैलकुलेट नहीं करेंगे ना, तो फ्रीक्वेंसी परसेंटेज तो आप कैटेगरिकल डेटा के लिए करें, उसका ग्राफ भी अलग होगा। कैटेगरिकल डेटा है तो आप उसके लिए पाई चार्ट, बार चार्ट बनाएंगे। क्वांटिटेटिव डेटा तो हिस्टोग्राम, फ्रीक्वेंसी पॉलीगॉन, स्कैटर डायग्राम बनाएंगे। तो इसी तरीके से टेस्ट ऑफ सिग्निफिकेंस भी वेरी कर लेंगे। कैटेगरी डेटा है उसमें आप फ्रीक्वेंसीज को, प्रोपोर्शन को कंपेयर कर रहे हैं, यू अप्लाई द chi-square टेस्ट, ठीक है ना। जहां पर आप कैटेगरीज को कंपेयर कर रहे हैं, जहाँ चीज उसमें परसेंटेज होती है या उसमें नंबर्स होते हैं या फ्रीक्वेंसी होती है, यू अप्लाई chi-square टेस्ट। यहाँ पर आप कंटिन्यूस डेटा है तो उसमें तो आपकी परसेंटेज नहीं, उसमें तो आप मीन कैलकुलेट करते हैं या मीडियन कैलकुलेट करते हैं। तो उसके लिए फिर आप ऑफकोर्स टी टेस्ट है या अनोवा है, मीन को कंपेयर। तो ऑल फर्दर एनालिसिस डिपेंड्स, if you are clear about the type of data, then analysis, data entry, further analysis become very easy.
Assalamualaikum, Professor Ashraf. Can I ask you one question?
जी sure, why not?
प्रोफेसर रिजवाना बोल रही हूँ। थोड़ा सा एग्जाम्पल के साथ रिग्रेशन एनालिसिस का बता दें।
देखो जी, जो रिग्रेशन है, रिग्रेशन है कि यू वांट, इफ यू नो द वैल्यू ऑफ वन वेरिएबल, यू वांट टू प्रिडिक्ट द वैल्यू ऑफ अदर वेरिएबल, ठीक है ना। तो रिग्रेशन एनालिसिस जो है टू टाइप्स का है मेनली। एक होता है लीनियर रिग्रेशन, एक होता है लॉजिस्टिक रिग्रेशन। जो लीनियर रिग्रेशन है ये क्वांटिटेटिव डेटा में हम वेरिएबल के दरमियान देखते हैं कि उनके दरमियान क्या रिलेशनशिप आ रहा है, कौन सा बेस्ट प्रिडिक्टर है। फॉर एग्जांपल आपकी स्टडीज के अंदर फॉर एग्जांपल एक एम्प्लॉय डाटा आपने कलेक्ट किया, उसमें उनकी सैलरी भी होगी, करंट सैलरी भी होगी, उनकी एजुकेशन लेवल भी होगी, और उसके अंदर उनका प्रीवियस एक्सपीरियंस भी होगा, ठीक है ना। ये सारी चीजें होंगी और उसमें आप देखना चाहते हैं, आपका डिपेंडेंट वेरिएबल क्या है, करंट सैलरी है। तो आप देखना चाहते हैं कि विच इज द बेस्ट प्रिडिक्टर ऑफ योर करंट सैलरी, ठीक है ना। तो उसके अंदर फिर आप लीनियर रिग्रेशन करते हैं। यू एंटर इंडिपेंडेंट वेरिएबल, उसमें कल इंशाल्लाह बता दूंगा। डिपेंडेंट वेरिएबल में आप क्या एंटर करेंगे, सैलरी, करंट सैलरी। आप उसको कौन से बेस्ट प्रिडिक्टर्स हैं उसके, आप जो उसमें आपकी स्टडी के अंदर हैं, आप प्रीवियस एक्सपीरियंस भी है, एजुकेशन लेवल भी है और प्रीवियस सैलरी भी है, तो सारे या बिगनिंग सैलरी है, उससे वो आपको बता देता है कि विच इज द बेस्ट प्रिडिक्टर ऑफ योर करंट सैलरी, ठीक है ना। ये तो हो गया ये लीनियर रिग्रेशन। दूसरा है लॉजिस्टिक रिग्रेशन। लॉजिस्टिक रिग्रेशन हम यूज करते हैं व्हेन द डिपेंडेंट वेरिएबल इज डाइकोटोमस, मतलब डिजीज मे बी प्रेजेंट और नॉट प्रेजेंट, मतलब हार्ट डिजीज में भी प्रेजेंट, उसके रिस्पेक्ट को स्टडी कर सकते हैं आप, एक्नी के रिस्पेक्ट को स्टडी कर सकते हैं, मल्टीपल रिस्पेक्टर्स को आप स्टडी कर सकते हैं, उनके एसोसिएशन दे सकते हैं। ये आपको आर रेशियो भी बताता है, आपको पी वैल्यू भी। इसका फायदा ये है लॉजिस्टिक रिग्रेशन का कि अगर आप जो chi-square से भी आप एसोसिएशन देखते हैं, वो भी यही काम करता है, लेकिन chi-square में तो आप एक रिस्पेक्टर को और एक आउटकम को आप कंपेयर कर रहे होते हैं। फिर आप मल्टीपल रिस्पेक्टर को साइमल्टेनियसली एंटर कर सकते हैं। सो कंफाउंडिंग जो वेरिएबल्स होते हैं, जो एक दूसरे को इन्फ्लुएंस कर रहे होते हैं, उनका इफेक्ट भी नलीफाई हो जाता है लॉजिस्टिक रिग्रेशन में। जो आपको फिर वो एनालिसिस मिलता है, वो आपको मिलता है, उनको टेक केयर ऑफ द कंफाउंडिंग वेरिएबल। तो उसके बाद भी फिर अगर कोई यूनिवेरिएट पहले कर ले, फिर उसके बाद मल्टीवेरिएट कर रहे सारे वेरिएबल को डाल के, तो फिर भी कोई अगर सिग्निफिकेंट एसोसिएशन रहती है तो दैट इज नेचुरली ट्रू एसोसिएशन। तो ये है लॉजिस्टिक रिग्रेशन का। we will have, मेरे पास है डेटा फाइल एक्नी के रिस्पेक्टर की, हमने एक स्टडी की थी लाहौर में कपल इयर्स बैक, लेडीज के अंदर केस कंट्रोल स्टडी थी, तो उसमें लॉजिस्टिक रिग्रेशन की थी। तो वो हमने मुख्तलिफ जो रिस्क फैक्टर्स दिए थे, जैसे एज है, सिबलिंग्स हिस्ट्री ऑफ एक्नी है, चॉकलेट यूज है, कॉस्मेटिक्स का यूज है, फ्रीक्वेंसी ऑफ ईटिंग चॉकलेट है, ये सारे रिस्क फैक्टर हमने स्टडी किए। तो वो भी आपको कल इंशाल्लाह जब हम एसपीएस करेंगे, हैंड्स ऑन एसपीएस, तो वो उसमें वो भी आपको दिखा दूंगा और कैसे कैलकुलेट करते हैं और उसकी आउटपुट को कैसे पढ़ते हैं। असल चीज है कि आप, एक तो होता है डाटा एनालिसिस, उसके बाद जो आउटपुट आपके पास शीट आती है डाटा आउटपुट, उसको कैसे इंटरप्रेट कर, ये भी इंशाल्लाह कल हो जाएगा।
जी जी, मैं एक चीज आपसे पूछूंगी, जैसे मैं एक स्टडी आजकल अपनी उसको कंप्लीट करना चाह रही हूँ, तो हमने वैक्सीनेशन स्टेटस असेस किया हुआ है। वैक्सीनेशन स्टेटस के अगेंस्ट हमने जो वेरिएबल्स हैं, जैसे एज है, सेक्स है, लेवल ऑफ एजुकेशन है, सोशियो इकोनॉमिक स्टेटस है, तो उनके अगेंस्ट प्रेजेंस ऑफ वैक्सीनेशन जो है, यानी दे आर वैक्सीनेशन है या नहीं है, इसको हम लीनियर या लॉजिस्टिक रिग्रेशन से रिप्रेजेंट कर सकते हैं?
हाँ, लीनियर से बिल्कुल कर सकते हैं, क्यों नहीं कर सकते। उसमें देखें, ये लॉजिस्टिक रिग्रेशन से जो फैक्टर इफेक्ट कर रहे हैं, तो नॉर्मली लेजिस्लेटिव, क्योंकि इसमें आपका जो डायकोट डिपेंडेंट वेरिएबल है वो है वैक्सीनेशन और नॉट वैक्सीनेशन। बस उस वैक्सीन स्टेटस को अफेक्ट कर रहे हैं वेरियस फैक्टर, वो नेचुरली आप लेजिस्लेटिव वेरिएशन से वो देख सकते हैं कि कौन सा वेरिएबल जो है सिग्निफिकेंटली इस वैक्सीन स्टेटस को इन्फ्लुएंस कर रहे हैं। उसमें वो ऑर्डर रेशियो भी दे देता है और उसमें वो पी वैल्यू भी आ जाती है, विच वेरिएबल इज सिग्निफिकेंटली, सो विच इज नॉट सिग्निफिकेंट, वो आप देख सकते हैं, कोई मसला नहीं। जस्ट डाटा एंटर हो जाए तो विद इन फ्यू सेकंड यू कैन कैलकुलेट।
थैंक यू वेरी मच।
वेलकम। एनी अदर क्वेश्चन?
ठीक होगी।
Okay, if there is no question, thank you very much. We can stop here. Inshallah, we will meet tomorrow next week. And after these 2 seminars, again,
thank you.
If you find any difficulty, you can just.
Assalamu alaikum, sir. I'm Dr. Usman Nasir.
जी
sir, I'm Dr. Usman.
जी डॉक्टर, आपकी आवाज नहीं आ रही।